Welcome back to another showcasing video. Today I want to show you a design I made about padlock. This is very neat design because normally people design padlock they have the kind of thing like leather with redstone lamp, and you have to make the right lamp turn on and the wrong lamp turn off, but it is not keeping the on ring at all. So this design fixed it, and I got the inspiration from Crafty Master Man. I saw one of his video had this thumbnail, and but I haven't watched the video yet. I think I'm gonna watch it later, but I want to design it myself first, then watch the video. Let me show you how this works. You have to enter the passcode in a specific order, and you totally can customize it. Example, I have right here the passcode is 1212, so I can just press 1, 2, 1, and 2 again. Then the door should lock itself. And if you put any other like type combination, it not gonna work. Or like this, you press 2, 1, 2, 1. Yeah, it doesn't work. But if you press 2 again, then the door should open because 2, 2, 1, 2, 1, and 2 had this sequence. So it is the right pattern code. By the way, this is the plus piston door. It is zero thing, but we are not talking about this math today. Yeah, we have a lot of improvement to do. First, we need to give each button in a signal strength. Like it is very hard to do that because they are so dense, like they are really next to each other, and you cannot present redstone like this. Yeah. My solution for this is use composter because it can produce signal strength, and also you can push it, which is very helpful because we can do something like this. We power the button quasi connect this piston right here, and this composter go down and give out the signal strength we want. So we have 1, 2, and 3. Other combustor only gives signal strength from 0 to 8, so the total is 9. But obviously we don't want to work with like 0, so we only have 1 to 8, and the padlock has 9 buttons. So we have to do something to fix it. My solution is just give it the full signal strength with the repeater and deal with it later, I guess. Alright, after we have like 9 different signal strengths, we have to literally combine all of them together into one single comparator line. And that turns out very difficult for like all of these. Also, I forgot about one thing. With composter, like you can boom mute it and the signal strength will increase, right? Right now it is 2. We have 2, 3, 4, 5, 6, and 7, 8. Do you see that? Like the converter when we fill in to 7, it turns itself to 8, and that is an issue, I guess. So I think we have to put two more blocks right next to the 7 and put this comparator into subtraction mode and subtract 1 although it is but after subtracting 1 the result is 7. And for combining them, we have to like deal with the upset right here. Like we want to produce a larger signal strength, and then when it comes out here, it will like produce the right one. So obviously we want it to be like closest to the line because yeah we can get everything larger than it. So it must be right here and next to it is as though n because yeah we will lose like one signal strength when we go to this line. And that is pretty neat. We do the same for sig. That is everything from the redstones. But like normally we have 9 here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But instead of that we have like the largest here is 15 and 1, 2, 3, 4, 5, 6, 7, 8 because when we put like 5 over here we kind of struggle to make it like up there with the correct signal strength of 5. Instead we rely on this composter to do the subtraction. So yeah we need to move it 1 to make the 5 at the corner. Next is how to do the padlock with your specific like numbers. I think it is very straightforward. For example, we let 2 goes in, we subtract it by its values but minus 1 meaning 1 because 2 minus 1 is 1. So if 2 let me do the real example like 2 here. Yeah, we have 2 comes in and when it is subtracted by 1 we would have the AND gate right here, which means we only accept when the result of the subtraction is only 1 but not 2 or 0. And if that is the case, this redstone touch will turn on and power this SR latch. The purpose of the SR latch is you can set it in value and yeah it will keep it. To turn it off you need to power it right here and it keeps unpowered although I'm spam the reset button but yeah it keeps its state. So let me do it again like we lock it with this button and yeah after lock it the signal strength is 13 and 13 is obviously not in our set. So yeah it is literally a dummy signal strength and after we put 2 in it not locking the signal anymore and this allows all the digits to come in and yeah open the lock. But what if we enter the incorrect one? Should this be locked by itself when we enter the wrong number? Yes, it is correct, but like if this layer right here sees the number is wrong and yeah want to send the reset signal to this and like to all everything above we gonna have the problem about we gonna have a problem about like the delay to communicate with all of the upper layers. So I don't like the idea at all. And to know if we enter the wrong number, this repeater gonna output the full signal chain when we have any thing comes in other than zero, and we have to like wiring in to an, AND gate to see this thought right here. It is very difficult for the wiring from over here to here. So back to the drawing board. So my solution is we're gonna do everything in parallel, which means if we enter like a number like 9 will be distributed into like all of them at once. And yeah, we have no delay to go through each. In conclusion, we have the logics right here. The first lock always open, right? We already know that for the number to goes in. For the current lock, if the number is correct, open the next lock like the one below it. And yeah, after it check or always close itself. Alright, back to Minecraft. We split them into layers with this design right here, and everything is parallel. Enter all of the locks at the same time. The logic for checking if it is the correct number still the same. We subtract it with its value -1. So this should produce only one signal chain, and power this touch on when if it is correct, and we still have the SR latch. If this touch is on, it gonna like turn up this SR latch, and currently the SR latch is like block the signal come through this connector by subtraction mode. But if this is on, like we can break this. Yeah, it is on right now, and the layer below is like open, and the signal can come through. The repeaters right here are doing the reset itself job. You can say it always try to lock itself, but when this touch is on and it try to lock itself, it is not gonna work. So that is how this system works. If everything is correct, we can do something like play this node, and also we need to like reset everything too, because if we enter the correct number like 1212, and then we still continue enter 12, it still say it is correct sequence from 1212. But after this is correct, we should reset it, and request the user to enter 12 again, not just only 12. That could be confusing. Okay, let's test it by speed up the game. So we don't have the awkward silence. Test any other combination, or you can enter 2 a bunch of time, 1 a bunch of time. You can see it is not open right now. Let's enter the correct sequence. 1, you see that that touch is on. 2, and the second one is on. 1 again, and the third and the first one is on. I don't know, that is not the first one, but the second one. And final is 2. And the node block is blind, and we reset everything. So we enter 12 again. it's not gonna work until we add more 1 and more 2. Now let's try to customize my own sequence. Like I want to have 9, 5, 1 and 2. So the first one is 9. The first one is 9 and yeah, it is on the top layer. But we are not gonna enter like a barrel with the signal strength of like 9 because as we know this is not actually 1 but it is a special thing and yeah did e1 and did 2 3 4 5 6 7 8 so actually we don't have 9 here so just pretend it is like 9 minus 1 so we enter 9 minus 1 and yeah this barrel is for the subtraction so we minus 1 again which means 9 minus 1 and the result is 7 so we get a barrel with signal strength of 7 right here and yeah do the same for all the layers 5 is 3 and we have one is a special case because yeah when we power 1 the signal right here is 10 it is 10 so we have to use like 10 minus 1 again so it is 9 or you can like say it is 11 and minus 1 oh is still 9 but 3 here 9 here and then 2 is 0 nothing inside 9 here 3 and yeah 7 so let's test it with all the anything like 1 2 1 2 1 2 yeah it's not gonna work people can look at the touch to guess the correct number like try everything 1 no 2 no 3 no 4 5 6 7 8 9 9 is turned on which means the first number is 9 is correct but to try this one like 1 it turned up so it is very hard to guess because yeah each time the number is like longer it yeah it is 9 5 so yeah next no not 9 5 6 but 9 5 no like that is very hard so the correct one is 9 5 1 2 yes it is correct so that is it for today's video thank you for watching and yeah bye bye see you on the next episode